Hi students, we just did molarity, which is a way that we can quantify concentration. And now we're going to do mass volume percent, which is another way to classify or quantify concentration of a solute in a solution. And mass volume percent is something that we often use for medications. And what this is the mass of the solute dissolved in a given amount of solution, and it is grams per milliliter. So when we were doing molarity, that was moles of solute per liter of solution. And now we have mass in grams of our solute per milliliters of solution. So it's a little bit different. I want you guys to keep in mind that this is also called weight volume percent. So sometimes you'll see percent W over V instead of percent M over V, and it's the same thing. Now, looking at the picture below, we can see a label for amoxicillin. And this is an antibiotic that's often given to children for ear infections. And so most of us have had amoxicillin before in our lives. And it's this yummy pink stuff right here. Or if you don't like it, it's the yucky pink stuff. Now, what you'll notice down here is that the amoxicillin right there, how the mass volume percent is labeled for this stuff is it'll tell you milligrams per milliliter. And that's because usually when we have pharmaceuticals, we take them in milligrams, not in grams. But don't worry about that. We can switch it over really easy because we know how to go from milligrams to grams. So again, notice we've got mass over volume there. All right, so let's do some problems. So we're going to dissolve 5.66 grams of potassium bromide in enough water to make 27 milliliters of solution. And we want to know what the concentration of this is, and we want to know it in mass volume percent. Now this question should look pretty familiar because we did it back in the molarity section. But the answers are going to be different because we're using different units here. So let's just go ahead and write out the equation for percent mass over volume so that we can see what we're doing here. So we have mass of our solute, and that is in grams if we're doing it the standard way. And then we have volume of solution on the bottom, and that's in milliliters. And we're going to multiply this by 100, which is pretty typical when we're doing a percent. So here we can just plug and chug. So we've got percent M over V, and the mass of our solute is 5.66 grams. And the solute is specifically KBr, potassium bromide. And then we have volume of solution, and this is in milliliters, so that's right there. We have 27 milliliters, and we want to multiply this by 100. Now notice that's kind of easy because we didn't have to change grams to moles, and we didn't have to change milliliters to liters like we had to do for molarity. So if we go ahead and punch this into our calculator, what we're going to get is 20.9. But what you'll notice is 27 only has 2 sig figs. So we're going to change that to what? To 21. Now we need to label this, and how we do this is we say percent M over V, so we know which concentration units we're doing. And we also have to go ahead and put the solute because we need to know what's in there. So 21% M over V KBr is the concentration for that solution. Now number 2 says we're going to dissolve 4.44 grams of sodium chloride in enough water to make 0.075 liters of solution. What is the mass volume percent? All right, so our mass here is 4.44 grams of sodium chloride, and that one's just fine. We can leave it that way. And our volume is 0.075 liters. And in percent mass over volume, we typically do grams per milliliter. So we're going to go ahead and switch that over here. And in order to get from liters to milliliters, what we would do is use a conversion factor. So we're going to put liters on the bottom because we want to cancel that out, and milliliters on the top. And then we have to know how many milliliters are in 1 liter, and we should know that by now in this class, that there's 1,000 milliliters in a liter. That cancels out, and what we get is 75 milliliters. Okay, so let's put that into our equation. So percent M over V is going to be the mass of the solute. So we've got 4.44 grams of sodium chloride divided by the volume of the solution, 75 milliliters, times 100. And if we put that in our calculator, what we're going to get is 5.9, and we're going to leave it there because 75 milliliters has 2 sig figs. And the way that we label this is we say it's percent M over V, that's our concentration unit, and we identify the solute, which is what? It's sodium chloride. Okay, so moving on to number 3. Number 3 says that we have a 3.98% M over V sodium bromide solution, and we have 350 milliliters of that solution. We want to know how much NABR was used to make this solution. So right here it's asking you for mass. Okay, so let's just remind ourselves we have percent M over V is equal to mass of our solute in grams, and we have volume of solution, and that's in milliliters, and we multiply this by 100. So if we just put the values that we have into this equation, we'll see what we have to solve for. So we have 3.98% M over V, NABR, and put the equal sign, and the volume of our solution is 350 milliliters, and that should be a capital L there, and we have multiply it by 100, and we don't have the mass of our solute in grams. Oh my goodness, I made a mess of that. Let's see if I can fix that a little bit. NABR equals mass of our solute in grams. Okay, so we have to solve for the mass of our solute. So we'll go ahead and we'll put 3.98, and we're going to write out the units we had here. So that would be grams over milliliters. And we're going to go ahead and move 350 diagonal across the equal sign, because remember, that's legal. It's the magic of algebra. And we're going to move 100 diagonally across the equal sign, so it's going to go underneath 3.98. So we have 100 down there, and that's going to equal the mass of our solute. Okay, so the milliliters cancel out because you have milliliters on top here, and then you have milliliters on the bottom there because it's grams over milliliters. You could have also written this milliliters down here, but we just didn't. And then we go ahead and we do the math, and we can see from the problem here that we're left with a unit of grams, which is really good because we're solving for mass, and grams is a unit of mass. And when we do the calculation, what we get is 13.9 grams of NABR. And that is our answer right there. All right, number 4 says calculate the mass volume percent of amoxicillin in the pink medication pictured in the previous slide. So right here, we've got 200 milligrams per 5 milliliters. And the question's asking us to put it in the standard form right here, where we have grams over milliliters. So our mass is 200 milligrams. So we have mass is 200 milligrams, and our volume is 5 milliliters. And if we do percent M over V is equal to mass of solute, we can see that we need to switch 200 milligrams to grams, and volume of solution, we can see that we can leave 5 milliliters as 5 milliliters and multiply that by 100. And that will mean that we're going to have 0.2 grams, because you would take 200 and divide it by 1,000. So we have 0.2 grams, and we divide that by 5 milliliters, and we multiply by 100. And that is going to give us 4, and that's percent M over V, and that would be the amoxicillin molecule. So in that bottle, if we did the percent M over V for amoxicillin, it's 4%. Alrighty, and that had 1 sig fig, and that had 1 sig, and that had 1 sig fig, and that had 1 sig fig. But we would hope that with a medication, it would actually be more significant digits than that, and they were just being easy on us and just saying 200 milligrams per every 5 milliliters. All right, so that's some practice on percent M over V, and next time we'll do percent M over M and percent V over V. But right now I want you to take a look at this calculation right here and go back into the molarity section and take a look at what the concentration of KBr looks like if you're calculating the concentration in molarity. All right, see you next time. Bye-bye.